free, I'm going to profit. After a while of thinking, my plan further manifested into writing a REST microservice, writing a GraphQL middleware in Swift, and then that would solve all my REST issues. So if we come to the execution that I actually had to go over, or what I had to do to reach this goal, I first had to discover all the available options, right? I was new to the Swift or server-side Swift and backend. I never actually developed anything on the backend, right? It's particularly not in Swift. So I had to discover all the available options. Next, I had to find someone to do the actual work. At the time, I had an intern sitting down there. Hi, John. So I had to find someone doing the work, right? Like, you cannot like do both parts of the equation. That would be too much work for someone in my position, right? So the next thing was like, I wanted to deploy the backend and consume it in iOS. And so I started my discovery and found like that there's three major server-side Swift frameworks today: Vapor, Kitura, and Perfect. But I needed a way to evaluate those, right? So I needed a way to quickly evaluate which one is the best framework, or which one is the framework that fits my needs the best, right? So we all know the to-do application that many programming languages or many programming tutorials start out at. And I thought to myself, why not write a REST backend service in each one of those frameworks and then see what fits me the best, what has the best benefit over what I need it for. So at first we're going to look at Vapor. If we wanted to implement like the to-do application that I just mentioned, or the to-do REST microservice, we would write a controller and a model view controller kind of style pattern. The controller is very similar to what you know in like the controller on the iOS client. The controller basically registers your routes, and the route basically dictates when you're calling that route which endpoint is being called or which logic is being called, right? So you're registering the get endpoint to-dos to the handler index, and the index will be called. You're passing by the query, and you're returning all the to-do items there. Globally, Vapor gives you a routes function where you have a router as the calling side. The Vapor calls the router. It registers all the endpoints here, and you basically can either do this in the router itself, or you can do this in the controller and register the routes in here. And the most important part for me was the model, right? Because I wanted to get rid of all the optionality. Like if my backend is written in C#, and they might have a question mark or might not have it behind the property that you're doing, optionality is the big thing. So I wanted to be able to write the model and the similar way that I write it on the iOS client. And on Vapor, you can basically do this by the same way you're doing it on the iOS client. You write your class as you do usually. You conform to Vapor-specific protocols, in this case SQLite model, migration, and content, plus parameter. You see, we don't need to do any kind of specific implementation for those. And nicely enough, content conforms to decodable and encodable. So Vapor gives us already codable out of the box. So to summarize Vapor real quick, like Vapor is purely written in Swift 5. It was started as an open source project. It is still an open source project. I consider it the most open source project of all the three. Codable is baked in via the content protocol. You have native database connectors, so within Swift you can connect to all the database. You can think of the splitter you want for any major or somewhat minor even databases. It has a native templating language if you want to create a website with it, or it has a ORM engine Fluent if you don't want to deal with all the SQL statements, which I don't advise you to do. There's literally almost unlimited hours of tutorials on Vapor University, Vandalic, and so on, because it's a very open source project, right? So a lot of people tend to write about it. Vapor Cloud is an easy way to deploy any kind of REST service that you have there. It has very fair hourly pricing, so this is their own cloud where you can easily deploy via your CLI your project later on. Next up is Kitura. So Kitura is very similar to what we've seen on Vapor. It's being developed by IBM, so it has a little different take than what we've seen on Vapor. But first up, like the routes look very similar than what we've seen on Vapor. You basically register the route against the handler is being called. The handler is built in an application, And here's the first part, which is kind of different here, right? We've seen a request coming in and coming out of the Vapor handler. Here we have a completion block that basically is a typed completion block at the time already. So we can deal with the elements itself or with the objects itself. We can deal with the error. And this is our completion block that we have to deal with. The model, on the other hand, is a little bit nicer, in my opinion, than what Vapor was doing. They're using more vanilla Swift than what Vapor. Vapor has a lot of nice protocols for you that are already working out of the box. But if you ever wanted to do any kind of model sharing or code sharing, you would end up having to subtract what's part of Vapor versus what's part of Foundation or what's part of Swift. And so they're using codable and equatable or codable directly. That was one too fast. So Vapor is purely, Kitura is purely written in Swift, Swift 5 currently. It's developed and open sourced by IBM. It uses and exposes the codable protocol directly. Uses query for SQL abstraction layer, so this works a little different than the ORM layer that we've seen before. It is essentially an ORM layer, but it abstracts the SQL away. It has large availability of middlewares and adapters. So typically for IBM, a big company, they have a lot of connectors for the software that your company might already be using. Tutorials and documentations are provided by IBM. We've seen a talk yesterday about this, I think, from someone from IBM. There's a lot of tutorials there. Some of them I found outdated, but you usually get along with those. It's a first-class deployment on IBM Bluemix Cloud Functions, which is based on Apache OpenWhisp, which currently supports Swift 4.2. So they're working on it's an open source project, Apache OpenWhisp, that they're currently working on Swift 5 integration. Last but not least was Perfect. So Perfect works a lot different, in my opinion, than what Kitura and Vapor works like. Perfect is being developed by a startup in Canada, and while you have a handler in the completion block, they work a lot more on getting basic text strings out and basic responses out, so you have to do a lot of more boilerplate code working. They have a lot of convenience functions, but oftentimes they don't match, or oftentimes it's hard for you if you wanted to abstract your model away from the actual implementation of the framework to be able to share it with the ISO side of things. We have to do a lot more work, or would have to go down to this. And the other part that is somewhat annoying, while they have typed endpoints where you could be using codable, they still rely a lot on their own JSON convertible object, which I think is a performance thing. So Perfect praises itself to be the most performant of all the three frameworks we've seen. I cannot say if that stands true because I get very different results based on your usage and your cases and what you are actually using on. But essentially, if you wanted to use any kind of JSON converting, you would do that for their own protocol instead of using codable. It is mainly a mix of C and C++ bindings. While they're moving towards 100% Swift, and while the repository is 100% Swift, they have a lot of underlying C, C++. Hence the language itself, the DSL that they're basically giving you, or not even the DSL, the method definitions that they have in Swift are somewhat different from Cocoa Touch. So it doesn't feel as natural as Vapor and Kitura felt like when writing a backend service in that. So it's, like I said, it's developed by Perfectly Soft, a startup in Canada. It uses its custom JSON implementations. It has the biggest number of connectors, so they have a lot of repositories out there, so many that they had to split up their GitHub organization. Some of them are outdated though. And they have a native database connectors, and their Storm is their ORM. They offer deployment via a desktop application to AWS, which is essentially a Docker binding tool. So what would we have to do if we would want to do model sharing or code sharing? So the idea with model or code sharing is that you transform anything that is sharing the same dependency on both your front end and back end into its own package, and you import the package into both the server and the front end. So that basically leaves you to either having to go a way big workaround of abstracting what your dependency cycle looked like, or you're going to use something like Kitura that already does that for you. Simply because Kitura relies on the same components, the same vanilla Swift components. You can extract business logic, but then again you would have to do the abstraction that you've been seeing. Shared code always goes into the additional like SPM package. Like with Xcode 11, we're gonna have like first-class SPM support, Swift package manager support, which makes this very easy. Now here's the big thing. Normally in any chemical equation, math equation, you put in the same things, you get the same output. Not on Foundation. So if you put in the same thing on Foundation macOS versus Foundation Linux, you not always get the same output. So they're differently implemented. It's a big issue in the Swift server-side community. So this is something that you have to keep in mind. A lot of the code that you see out there currently has a lot of if-else clauses, if OS Linux versus if OS macOS, specifically for this reason. So I tried to summarize my findings to this point. Keep in mind, these are somewhat opinionated from a developer that's like working with these things. Vapor has a very, very nice CloudKit syntax, right? It's an open source project. Everybody can help out on. They're always up to date, and therefore they're following like what we've seen otherwise on iOS. So I give it 3 pluses. The community size, which is somewhat like a non-saying metric in my opinion, because a lot of community doesn't necessarily mean like that you have a lot of quality content. There's all the 3 pluses because they're the most starred one on GitHub. They have a huge Slack community. But what really stands out for me with Vapor is that there's Ray Winterlich tutorials, that there's Vapor University, and that they have a huge support channel on Slack. The library availability is somewhat wonky, but like 2 pluses is still pretty good. Like if you don't have many dependencies to another programming language, there should be no issue for you finding a library. And the deployment options, like I said, they have the Vapor Cloud. You can start for free with a very low tier. As soon as you need more, it is $7 per month, I think, for like a little bit more RAM. So this is pretty much perfect that they have like the opportunity for you to deploy your REST service onto their own cloud. Gitura are very similar to Vapor. I think while they're not cooperating directly, since IBM is a big company, Vapor is an open source project by individual contributors. They are very similar in how things work, right? The only very big difference, I think, is the community size, which is a little bit lower since it's IBM. That has a lot of control over the content, and the library availability is a little bit better since they have a lot of software and know a lot of like what companies are doing today, so they can tailor it towards that. Perfect. On the other side, I mentioned it already. The syntax feels a little bit wonky. It feels a little bit more like writing C# or like a first-class server-side language, rather than what we are known from CloudKit Touch. So that's why I give it a minus there. The community size shrinks since they're not as active as like the other two libraries, and the library availability, like I said, is somewhat outdated at this time. Again, take this with a grain of salt. It's an opinionated thing. So server-side Swift writing a microservice. So code sharing takes its tolls because you have to basically tailor your backend and your frontend to make it work, right? So there is somewhat a toll to it that you have to just switch the way you think, switch the way you're currently implementing things. So it's not always perfect, but we're going to come to a very nice solution for that in a bit. Vapor and Gitura are very easy entries for simple REST APIs. If you wanted to just write like a REST API and get your feet wet basically in the world of backend development, Vapor and Gitura are very nice options for you to start out today. So Swift being compiled versus interpreted, like JavaScript, as we all know, is interpreted, while Swift is being compiled, ends up in a lot of less resources that we need to run the same kind of code or the same kind of web service. This is again somewhat opinionated and depends on what you actually need to get the job done, right? And Foundation being different is just table flipping, right? Like you want to flip the table once you put in the same thing and you're not seeing the same output. Now let's get to the second part of this talk, GraphQL. So again, a show of hands, who in the audience knows GraphQL today? Perfect, I like that, because I have a little primer for you what GraphQL is, so we're going to go over this real quick. So GraphQL tries to compete with traditional REST. In traditional REST, we usually have like endpoints that are already tied to the model that we're getting, right? So on a person's endpoint, you're usually getting a person's model. Yep, I got that. Post is the same thing, right? You query for post, you get a post endpoint, right? Or you get a post model. Now, GraphQL tries to make this different, right? We're trying to detach the endpoint from the model that we're getting, right? So when we have the GraphQL endpoint, we are actually asking the endpoint, or we're telling the endpoint what we want. We say we want all persons, we want the name of all persons, the age of all persons, and then for like each one of these persons, we want the post that they have, and the post we want the title, right? So on the back end in our database, whatever we're going to use to persistently store our data on the server, this could have 100 fields, right? But if we're only interested in these 3 or 4 fields, or even in these mix and match models, right? Then we're telling GraphQL like, we want this, do the mix and match for us, and we're going to get back the model that is all of that, right? So you see, we get the all persons back, the result of our query, we get the name, the age, the post, the title, and the same thing for all the persons, right? So how does GraphQL does that? GraphQL is somewhat a middleware. So depending on how you like starting implementing GraphQL, you can either put it on top of a database and actually like have the GraphQL server do all the work, or you're doing actually a GraphQL middleware that is the only way of communication between your client and your backend. And the GraphQL server, this resolves all the connections to the legacy server, to the microservice, to the third-party API. So you're basically retrofitting a REST service that you already have to work with GraphQL. So I wanted to do that with Swift, right? So I was very frustrated with the REST endpoints that were given by my backend team. I was frustrated by the way designers came up with these views that would have like different things in there, like different model types in there, or different kinds of information, which ended up in me like fetching n times the amount of like information needed, right? So I wanted to introduce GraphQL, and I've been bugging my CTO for this for a good 2 years now, with always coming soon as the answer for that, and I couldn't wait anymore. But I didn't want it to do Node.js, and Sean didn't want it to do Node.js either, right? So I ended up looking for what we could do to get a GraphQL server written in the language that we already know today, and that is Graffiti. Graffiti is a library built by a single contributor that, like, there was a 4 framework initially called Savo. He pitched from this framework towards building Graffiti, which is a GraphQL server similar to the servers that are available in Node.js that basically help you building a GraphQL middleware in Swift by defining a few things. He built a whole framework around it. So how does that look like? What would we have to do to implement a GraphQL middleware in Swift? It's relatively easy. First, you're going to start by defining your entities. You define them the exact same way that you define them in a traditional REST environment on your client. There is no Graffiti magic at this point. So you all see that we have codable protocols. We can use structs, classes, enums. This is all very nicely done. And vanilla Swift again. Next, you would define your resolvers. So in this case, we're going to use a persistent store locally, but this could be any kind of asynchronous fetch with any serial session, or with any kind of like backend resolver where you're fetching a third-party API. So you're defining basically what your route looks like to get the character, and you define it again in vanilla Swift. Why am I going to be such a stickler to the point of vanilla Swift? Because you could share this with another client that might not want to use your GraphQL, or you could export it from your existing client towards the backend, right? The next part is basically repetition again. You're defining the API definition, but this time you're bringing in Graffiti. You basically have the API definition, the API context, call the resolvers, and you're going to define what your API is going to look like. Next up is the schema definition. You're defining, and this is a very particular Graffiti and like GraphQL thing again. You're defining what types, interfaces, unions, and queries you have. Like basically, you're giving the definition what the outside or what like the world can read from your API, and you're describing it, which is a very nice feature. We all know the Swagger pages where you can like look up information. Quite often, information is missing on these pages. And that's exactly what like GraphQL is also trying to do. You all have introspection where you can basically ask by putting in a query underscore schema, and you would get back like a description of the API, and you would see your unions, your types. So you're basically defining that in a union between the search result, planet, human, and droid, you can get this as a union back if you wanted to mix and match the results. So if we would put in a query similar to this, where we wanted the hero name query, right, where we wanted to query for all heroes, get all the names, we wanted to query for all the heroes' friends, the names in which movie they're going to appear in, it would, after all the code that you've seen, which is not very much, we could like query this as a schema, query our schema that I just showed you, execute the query, and this would be the result type, right? Very nice in my opinion, because I don't have to make n times n calls. I don't have to make n times 2 calls. I only have a single call that I can stream through. Now it gets even better. Like, you might be wondering what the server loop looks like, right? So whenever you have an executable, it's very different from what we have in the iOS world. In the iOS world, we have basically a main Swift that we don't see, or a main Objective-C that we don't see, that is constantly running a loop, that's basically constantly running an app delegate. Now on the executable side for Swift, we are constantly running a loop too, right? But that's basically the loop that we define. Now you don't see a loop here, except the event loop group, which is a different thing, trying to get into the asynchronous thing. But what we can do is basically run this as a service, as a Lambda service for those that use AWS, or a Cloud Function service that is only being invoked whenever a request is being sent. So your execution time will be very minimal, and you could very easily deploy this in a middleware that only ever needs to be called when your API is calling. You don't need to loop through the server or like block port 80. You only ever need to invoke this when needed, which is very nice. So what are my deployment options, right? I could use this in conjunction with Vapor Kitura and have this blocking loop, or build a front-end service to the back-end service kind of that would like stream my request to the Graffiti service and basically do that. I could streamline it through Apache Nginx. Basically, if I wanted to use Kitura, I could do that via fast CGI. I could use the Vapor Cloud, Docker, or bare installation on AWS. I'm a Docker fan, so I would definitely execute that in Docker. So we're almost at the end and we come to the summary. So what do we want, like Swift or Node? What did I come up with? So Swift is a fast and type-safe language, as we all know. It has a very low memory footprint, and the type safety is a joy to work in. If you don't have to deal with like the non-type safety in JavaScript, it's very nice for you to work in like Swift, having the type safety, having the possibility of defining your entities and actually relying on what kind of type it is. It has great error handling. I personally think that Swift error handling is great if you have the chain of doom kind of, where you know that like at the end it will fail here and you have an actual error type. That's, I think, nicer than what a lot of like the JavaScript frameworks do today. The iOS integration with Apollo is fantastic. So we haven't talked about this since it's a whole other topic and it deserves its own talk. But essentially, when you have a GraphQL scheme, or when you have a GraphQL server that you can query, it is relatively easy for you to integrate a GraphQL server into your iOS application. You don't have to write in a function for each endpoint anymore and rely on a whole architecture. Basically, there is a framework called Apollo that you write your GraphQL query that you need for the view controller, and it will auto-generate the code for you and make this available. There is also integration for automatically caching. There's integration for automatically updates, where you would basically get a WebSocket update if the information changes on the server. So this is a very nice thing, and the integration with Apollo on iOS is fantastic. Even though it's not in a 1.0 yet, which has been out for I think 2 years or so, it's been used in many production apps. Node, on the other hand, I smashed it a little at the beginning, but it has extensive support and is widely available. Think of it like the amount of tutorials that you can find in implementing a GraphQL server on Node.js on top of your traditional REST servers is times 10, times 100. Easily. Everybody does like Node.js these days. So you have an extensive support and it's widely available. If you ever needed to extend your server that you already deployed, it would be probably not an issue. It would be super simple. But if you have a Swift server that you need to integrate with some exotic C# database or Microsoft product, well, you might be screwed. Deployment is also way easier, right? Like like in the deployment side of things, like Node.js is accepted at Lambda directly. You don't have to upload a Docker image or deal with any of that, and that's usually what you want. But again, like deployment is kind of like if you would want to go with the Kitura side of things or the Vapor side of things, there is first class support. You're paying a little bit more, a little bit of toll, but then again, you're not locked in with Amazon AWS that eventually is going to charge you 10 times the price. There's again more learning resources and helps available on the Node.js side. So that brings me to the point of like when I'm going to use what are my use cases? When do I want you guys to use server-side Swift? In my opinion, like if there is a server-side Swift library already available, like it is with Graffiti, I think this is a no-brainer. Like for us, like this makes a difference of learning like Node.js for 4 weeks or having to code it underwater so nobody sees you crying, right? This is the difference in my opinion. If that's available already, if you don't have like this big need to integrate it with like 20 other servers, that's a no-brainer. Are there no external dependencies? Like as I said before, this would be a no-brainer for me. Is it like, do you have a complex need with other services? Probably not. And if you're still on the verge, think about it like, but it's Swift. Yeah, you probably want to do it. So I wouldn't probably like suggest this or I wouldn't probably use the 5-second attention span of my CTO to tell him like, we're gonna use like Swift as this new language and you're gonna trash everything else we have today. But I would probably like use those 5 seconds to tell him like, I'm gonna do that and maintain it myself. And if you can't do that, and if you can confidently say that, I think it's a fun ride. Which also brings me to a step further. Like if we look at the history of server-side Swift, in WWDC 2006, they announced that server-side Swift is going to be a thing. Shortly after, Vapor, Kitura, and Perfect got released, which also shows like how strong the community is, how strong the will is to take a language from where it was as an iOS front-end client language to a server-side thing, because it could be a very nice collaboration. In October 2016, Apple did the server-side working group, right? So for the first time, like there was this working group that was looking at issues and how to push server-side forward. And Swift NIO, which is an asynchronous server that we've seen in another talk here already, was accepted in September 2018. And that brings me to the next point, like Redis, Postgres, APNS, HTTP native clients are coming. What does it mean? So native clients means that they're coming from the server-side Swift work group. Vapor and others already have them. So if you wanted to do like a project today where you needed like any kind of like APNS support, you could do that already. And that's the whole point, right? Like Node.js wasn't like suddenly appeared one morning in the middle of the desert like the Terminator, right? Node.js basically was created by you guys, like, right? Developer like you and me. So like 2020 could be you. If we start using it and if we start pushing it, it will be something more, right? Like Node.js only lives the way it lives today because it has a huge community, because everybody writes it, right? Swift, on the other hand, like is a language that is easy to learn, that is very nicely done, and it has a lot of resources, right? So why not transfer that knowledge onto what we have on the server side today and extend it? And that's the end of my talk. If you want to reach me, you can take a picture of my PK wallet pass. And you can have all my contact details on that. I'm available the rest of the day and tomorrow morning, so if there's any questions, feel free to reach out to me. Happy to discuss. Thank you. Any questions? Oh. Yeah, over there. Sorry.
So we've got shared structs for our model objects, but is there anything helping make sure that it gets hooked up to core data locally versus the SQL on the server side, or are we still writing two different ORM linkages?
So I'm trying to repeat the questions so everybody hears it, and so that I'm sure I'm getting the right question. Like the idea is of like we're sharing structure in our code, in our shared code. But can we share core data or SQLite extensions?
Or any sort of framework that helps automate that.
As long as it's like compatible with server-side Swift, as long as you can use the framework both on the iOS side of things as well as the backend side of things. As long as you don't have any breaking dependency that is incompatible with one of the architectures or incompatible with one of the available frameworks that it's relying on, you can always share all kind of code that you want, right? There's no limitation set by Swift itself. Like think of it like when we talk about hybrid native apps. Like I'm not sure if anybody's familiar with Xamarin, but Xamarin was saying like you can share basically any code. But as soon as you were pulling in like different dependencies, like I want to deploy this on iOS, on Android, and Windows service, your amount of assemblies went down to such a minimal thing that you were lucky if you were able to print out a string, right? And it's very similar to this. Like, while Swift has a huge intercompatibility, and while Swift allows you to like work with Foundation, it really depends on what your dependency is, right? If you're depending on UIKit, you cannot port that, right? If core data is available, which I don't think it is on the anywhere outside of Mac OS X, right, or iOS, then you can't use that, right? But SQLite model, for example, that Vapor was using, if you want to have like local persistency with an SQLite model and the library that it's depending on, you can totally share that. And you can use like a point of abstraction where you have a local cache, local persistency on iOS, while you have a persistent store on the server that's actually saving everything. And that's the same with the business logic, like, or the validation. If you have a kind of like string validation for email addresses or zip code validation, that's exactly what you can do. That's what the whole thing is intended for. Did it answer your question?
I guess, yeah.
Okay. All right, Levi.
Yeah, you mentioned that you could deploy to Lambda with Swift. Wasn't aware that was a supported language.
So you can essentially upload to Lambda any kind of Docker image that is running your runtime, and then you can basically upload your running code, right? And this is what Perfect does with the native desktop application. You basically bundle your application inside a Docker and uploading it to Lambda. It's a somewhat painful process that not always works as like you intended. There are file size limit, Docker limits, and such things. But it is definitely possible and needs the kind of like development expertise. Yeah, back there.
As a follow-up to the conversation about sharing models, is that also true when you're talking about related relationships and other things? Because when you have relationships inside of Vapor or other things like that, those don't map the same way they would on the front end, right? You have to map them to like references to the database, and then so that would not be shareable. Are you talking about like standalone models? Because I've noticed with Vapor especially, which I love, that as soon as you start getting into complex data models and relationships, it's very broken, and it becomes like you have to write a lot of boilerplate code to get the same kind of thing you can get quickly in Rails or something like that. So I just wanted some clarity as far as you meant about sharing models and how that works with relationships on the SQL side versus relationships on like core data or how you do it on the front end.
Okay, so to repeat the question, is there any way to share the models or share models that have complex relationships within each other or reference each other? That's a correct question, right?
I think that's close enough for the recording answer.
Okay. Well, I'm not a native speaker, so I'm always trying to repeat for myself too. So as soon as you're getting into actual SQLite relationships like the one you were describing, where you have an SQLite model reference to each other, where you reference IDs, it is not worth going to trouble or going down the route of like exporting those to the level of abstraction that you would need, that you can share your models in between, right? And this is what I was talking about, like the tool that you're paying for code sharing. There's always this idea of never repeating yourself, but at the end of the day, you're repeating yourself 3 times around the church, in my opinion, by like doing the same thing different times. So to answer your question in short, I don't think it's worth it. It is possible if you're going the route of actual like matching IDs and implementing a layer that is matching it on the actual foundation types. I've tried that, but it was such an ugly code that I didn't want to bring it on my presentation and destroy the presentation.
That's great, thank you.
You're welcome. Vince.
Is there any issues with your legacy websites having like special header files or anything?
For Graffiti as a GraphQL server, or?
Right, when you're trying to pull in from legacy.
Okay. So the question is are there any issues when implementing like a GraphQL server and resolving it to a traditional REST service or a legacy service? So I can think of many issues that you have, like we have a lot of backend services that convey information through a header field or different JSON outputs to the header content field and stuff like that. And as long as you can deal with it in Foundation Swift, right, you're fine because you can do that on server side too, right? But if you can't consume it in iOS or Foundation itself because there are some abstract TCP protocol that is actually not REST then, right? I wouldn't even deal with it and I would probably quit. Yeah.
What was the experience with Apollo? Like we tried it on that and it wasn't like really effective, so I don't know.
So the question is, what was the experience with Apollo? So we haven't made the full switch yet, right? Like, so I've implemented the server first, and before I'm doing the full switch, which is also a few months out. So far from what I've been doing and talking to other people, like Apollo works great for us. Like there's a few tweaks you have to do to the output format, but as long as you're like having it handle the API.swift file, which is auto-generated, you're fine. So you have to write these GraphQL files that are basically defining your model on the view controller, and then it will auto-generate the file, the API.swift file for you, and do that. There's even an Xcode add-on now that you can do code syntax highlighting for your GraphQL file, and it worked very nicely for us. Like we oftentimes have like designers come in and like we want to show like an account history or transaction history, and you have like these 4 endpoints that we want to like show in each one of these tiles that we have. And we're like, well, there's 1,000 tiles, or you want to show like 200 tiles at a time. That means 200 times 4 times the calls, and we don't have any persistency in the app. So like there's think of 800 edge cases, please. And that's usually the time when we change a design or when we change something, and that's exactly what I'd rather not do, because the design is not at fault at the time. The rest and people are not at fault. But yeah, I need a way to get the information. Cool. Anyone else? All right, go ahead.
You mentioned for performance, you were comparing to Node.js. I think you said it's a 10th of the RAM. Could you compare it to anything besides JavaScript?
So the question is like, I made a statement about like 1/10 that server-side Swift uses an average of about 1/10 of the resources that Node.js works like or uses. Did I compare it to any other language? So I compared it to C#, which is the prevalent language being used for our backend development. And we are way more, or Swift is way more performant on Linux machines than C# is if being run with the .NET. I forgot which version it is, but the basic .NET that's currently cross-platform. It's not about 1/10 like JavaScript is. I think JavaScript is mainly so like resource hungry because it's interpreted, right? So you have always the interpreter like trying your different paths, and like you don't have a compiled file that is actually already bitcode, right? So you're undergoing a lot more instructions to the CPU on Node.js than you do on a compiled language. Therefore, like C# wasn't as bad, but C# just naturally, because it's blown up in terms of like what the .NET framework does, it's a lot different than like the Swift frameworks that we've seen that do all of the heavy lifting for you, that have like a less of an abstraction to the CPU than like what Node.js has or what C# has. Anyone else? All right. Thank you so much again.